Okay, first I wanted to check the course update. So you have our announcement right here. So we log into your course portal. Click on FINA's 3322. I made an announcement yesterday, so I wanted to make sure so everyone aware of that. The final exam due date is Friday, May 8th. So I double checked the schedule for graduating senior. So this year, so we do not have a commencement, and so students have have the commencement either I think it's rescheduled um, in the winter time, or it's that's anyway it's extended, so I'm not sure what time is it. The final exam, originally I post an announcement, so I wanted to have graduating senior to do the survey because the university wanted to have your grade reported by May 4th at 1 o'clock. So that's the intention why I need graduating senior student to take the final exam early. So now we do not have that limit. So for all students, okay, the final exam for all students, including graduating senior students, the due date for is Friday, May 8th. So you have more time to prepare for your final exam. So any students who is going to graduate in May, so you can take your final exam by May 8th. So that's, I made an announcement right here, so everybody aware of that. And so where is the final exam? Okay, so you scroll down all the way down. So we have week 16, and then we have final exam. Okay, so the final exam, read that instruction. So we click on that folder, so you will see, okay, there's a final exam. So the final exam will be comprehensive, including all chapters learned from this semester. And the exam may include true or false, multiple choice, essay, and problem solving question. So that's the format of the final exam. So the final exam is timed for 3 hours. And you can see there is another one is called final exam Excel worksheet. So I strongly suggest you to to submit your worksheet right here. So you can click on that. Okay, so you can see you have the attached file. You browse my computer, so you can find the file you work on. So you just click on whatever that file it is, for example, and then you click on submit, right? Click on submit right here in the corner. So you submit that, that's going to be the worksheet. So the final exam is 100 points, basically around like 50 points come from your final exam, around like say about 40 points from your true or false multiple choice, and 60 points from your essay and the project problem solving question. Okay, so what type of problem solving question? So you might be curious. Okay, so basically all those questions are not going to be for you. It's not new. So it's so you have already worked on that. Is similar to the question you're working on from your weekly assignment. So your weekly assignment. So basically, I wanted to give you a brief review of the final exam. Okay, the final exam. Okay, so you need to work on some of those. Okay, so you need to the true, false, and multiple choice are coming from all chapters, chapter 1 to 13. So there's nothing to review there. So you have essay question. Okay, essay question is going to be your phase and learning. Okay, phase and learning. So I wanted to see you write an essay about your phase and learning and how you integrate into your phase into finance. This is highly related to the discussion forum. 4, you have, remember, so you have the CCB, hard cost, and also you have Wall Street Journal articles. So that's essay questions. And also you have problem solving question. Remember, so in throughout this semester, we have several very important the risk analysis using Excel. And the very beginning, chapter 1, we have efficient frontier. So I need to give you different numbers, and you work on the efficient frontier and Sharpe ratio. So you talk about the Sharpe ratio, efficient frontier, right? Well, that's we talked about it before. I think you, if you're still curious about what I'm talking about, you need to go back to chapter 1 and look at that. And also another important project is doing is the option pricing. The option pricing, you could have option, co-option, or put option using binomial model. So you have 1 step and 2 steps, right? So 1 step or 2 steps. Okay, 1 step or 2 steps binomial model. So particularly you need to review what is your, how to get your hedge ratio and the hedge ratio and the risk neutral probability. And then you calculate the put option or the co-option price. Okay, that's a binomial model. And another option pricing we talk about is Black-Scholes model. Okay, Black-Scholes binomial model is option pricing model. Okay, Black-Scholes option pricing model to have the co-option or put option price. And what else we learn? Okay, so we also learned, remember the gauge. Okay, the gauge 1, and exponential weighted moving average. So I give you data sets and you estimate the parameters for our GARCH11 model and the exponential weighted moving average model. So remember for exponential weighted moving average, you need to estimate the parameter, which is it's called lambda. And for GARCH11 model, you need to omega, alpha, and beta, right? So you have different parameters to estimate. And then you calculate the volatility and to show your the graph of your the volatility. Okay, the next one is the value at risk and expected shortfall. So we did a value at risk and expected shortfall in chapter 13, right? Chapter 13. So that's a value at risk and expected shortfall. Okay, and okay, so that's all I have. So any questions about that? Do you have any question about your final exam? Okay, so you really need to attach your Excel worksheet right here. Okay, so do not just simply type your answer in the content box. So you need to have this Excel worksheet attached to right here. Okay, today is this is chapter 14. So today is going to be the last lecture for this semester. So starting from next week, we are not going to have a Zoom meeting anymore. So if you have any questions, just simply send your email to me. So I would like to help. Okay, and to remember, so the last thing you need to do is to finish your final exam by May 8th, right? May 8th. So we're gonna edit this option is that the final exam is due by Friday for May 8th for all students. Okay, make sure that is for all students, including graduating senior. Okay, so final exam. I'm gonna change that. It's due by Friday, May 8th for all students. Okay. Okay. When you log into the meeting, please don't forget to just type your name in the chat box. So when you have the chat box, type your name for the attendance. So I will upload this video when we finish that. Okay, finish this this lecture. So I'm going to post this video on YouTube. Okay, I'm sorry for last time. I forgot to click on the video recording. So the lecture is not available on YouTube. Okay, today we talk about is the model building approach. So if you are going to form a portfolio, so when you have a position and worth 10 million in Microsoft shares, okay, you have a 10 million Microsoft shares. The volatility of Microsoft is $2 per day. If you use $2 times the square root of 252, that's around like a 32% per year. The total number of observation is 10, okay. The X is 99%. This is the confidence interval, confidence level. So the standard deviation of the change in the portfolio in 1 day is 200,000. So standard deviation of the change in 10 days, okay, is going to be that 1 day standard deviation times the square root of 10. Okay, so we assume that expect example. Here, the value is 0, so the expected change in the value of the portfolio is 0. You get the norms inverse, which is 1%. If the 99%, that means on the left tail. So the p-value is 1%, so it's corresponding the t or the z value is 2.329. So you can have the VaR, which is that as norms inverse function, you got 2.329 times the total portfolio value. That's the VaR. Okay, so when you do the VaR, and we can do individual project, and also we can have a two stocks, okay, in the portfolio, right? You can have 2 stocks in the portfolio. So you consider that a position of 5 million in AT&T, the daily volatility is 1%, and the standard deviation per 10 days is going to be that standard deviation times the square root of 10, and the VaR is going to be this 10-day standard deviation times the 1% z-score, right? So that's the VaR you have. And so if you consider like a portfolio consisting of 2 stocks in both Microsoft and AT&T, and the correlation between the return is 0.3, so you could have a standard deviation of the portfolio, which is going to be this formula is the square root the standard deviation squared times 2 times the correlation. Okay, this is what we did at the very beginning of this semester, chapter 1. So if you have the standard deviation and correlation, so the standard deviation of the change in the portfolio value in 1 day will be 220,200. So how you calculate that? Okay, you based on that formula. Okay, based on this formula, so you can get the standard deviation of x plus y. And then you have the 10-day VaR. The 10-day VaR, remember, is for this portfolio is a square root 10 times the norms inverse 1%. So this is the 10-day 99% VaR for the portfolio. And so the benefit of diversification is going to be, okay, this is portfolio, and this is the individual, right, 10% VaR for each individual stock, minus that the 10% VaR of the portfolio. So that's going to be your portfolio benefit is 219,000. Okay, and so I give you this one example we talk about right here. So is this is the final review, and also we have this example I told you exactly the same. So I will post this handout on Blackboard. Okay, the first step, we calculate the standard deviation of these 2 stocks portfolio. Okay, since you have the standard deviation for each stock and the correlation, which is rho 2 times the standard deviation, take the square root. Okay, so each stock, they have a standard deviation, which is 200,000 and 50,000. So X and Y, you substitute the standard deviation, and the correlation is 0.3. So, okay, with a correlation is 0.3, which is rule is 0.3. So the standard deviation of the portfolio is 220,227. Okay. Then you have the portfolio, which is 1 day 99% VaR. So how you get the 99% VaR is first you need to find out what is the 1% VaR corresponding to the Z value. Because the Z value we can do is using the norms inverse function. Okay, norms inverse function. So 1% is corresponding to 2.326. Okay, that's 1%. And so the 1 day 99% VaR is going to be the portfolio value and times the norms inverse function of the Z-score. Okay, that's this 512,300. So the 10-day VaR is going to be the square root of 10. Okay, you use this portfolio value times the square root of 10. Okay, so now you calculate the square root of the 10 days 99% expected shortfall. The expected shortfall you can calculate based on the equation we learned before from 12.2. Okay, so 12.2, where is that formula? The formula is right here, so we can show you. Okay, this is the formula for 12.2. So expected shortfall is going to be the mu times delta, and this is this part. Okay, so you have y equal to 2.326, and you have x equal to 0.99. So you can get expected shortfall. Okay, we have a similar assignment for you in assignment 4C. Okay, so I give you this example so you can to see how you get a solution for the last assignment. Okay, next I wanted to talk about if you using the correlation, how you get a correlation between different series. Okay, so last time remembers we have 4 different series of data. Okay, so we have 4 different index. So we using that historical simulation. So you get 4 index. So we use that data from chapter 13 again. So this is raw data we got, and it's already simulated and in dollar value. And then we calculate the return. So you can look at the Dow Jones, its return is C4 minus C3 divided by C3. That's the return for Dow Jones. Similarly, we do return for FTSE and Paris CAC and Nike 225. So all those index right here. Okay. And next we do is that we're gonna do the correlation or covariance, the return. So how you're gonna do that? So we have, okay, you go to data. So you remember you have data analysis button right here. If you don't have it, so you can go to file. Okay, you go to file option. Okay, click on add in. You go accept add in and then click on go. And you select the analysis to pack. Click on OK. Sometimes you need a solver, but not today. So you have that data analysis tab right here. Okay, you click on data analysis. Okay, so what you're gonna do is you do the correlation, right? So you find the correlation function right here. Click on OK. So you can input the range. So input all those correlation. Okay. We don't have, I think we don't have the labels on the top, right? So you just click on OK. So it will give you a correlation, right? The correlation matrix. Okay. So that's how we get the correlation. So you similarly, you can do this correlation we got here. So you can do covariance. So you do similarly, you do the data analysis, your data and the data analysis, and you choose covariance. It will give you the covariance matrix, right? Covariance matrix. Okay, so now you can see if you invest, last time we talked about the weight. So you invest 3,000, okay, this is 3 million, 3 million, 1 million, and 3 million in different for index, right? So you can make a portfolio and to see what will be your return. Okay, the portfolio variance is going to be the multiple variance of the portfolio. Okay, and the portfolio standard deviation is going to be the square root of your portfolio variance. The most important thing I wanted to talk about is the 1% VaR. So how you got 1% VaR is okay, it's called 1 day 99% VaR. Okay, it's going to be the Q36, Q36, which is the portfolio standard deviation, times the Q34. Okay, this is the 34 is the portfolio standard deviation, and this is the norms inverse of 99%. So 99% VaR is going to be the portfolio standard deviation. Okay, I want to remind you how we got the portfolio standard deviation. Do you still remember how you got portfolio standard deviation? Okay, this is the formula we use to get portfolio standard deviation, right? So if you have not 2 different assets, you have 4 different assets, so you just take the square root of each one, the square root of each asset, and then you 2 times correlation times the standard deviation for each. Right? So you got the VaR. What is the 99% expected shortfall? Okay, 99% expected shortfall is going to be we using the formula If we use this formula 12.2, you will get the expected shortfall for that portfolio. Okay, so the question is here, so we do is for this portfolio, we treat equal weight, so that's the weight. And if we use exponential weighted moving average, so let's say the variance is going to be changed. So we have that, okay, look at the return. So we did before and the same, right? So the first we get the data series and we calculate return. And for the exponential weighted moving average, so you need to assume what is the lambda. Okay, the first number we get the average return, average variance of this whole data series. And the second one is going to be using exponential weighted moving average formula. So you can say this is P4, okay, which is this one, times the lambda. Okay, lambda we're using N3. Okay, the second one is going to be using that formula, similar to all the other series data. So you have I4, which is this one, you take the square of the previous day's return and times 1 minus the lambda. Okay. So now you have the covariance. Okay, you have the covariance between Dow Jones and FTSE. So it's going to be, you calculate the covariance between Dow Jones and FTSE. So you select all this and using VaR function. And you get the covariance between Dow Jones and Paris CAC. So all those you get here. So now you have alpha, which is the weight or the money you invest in each portfolio. And you get the variance, covariance matrix. And then you take the square root, you get standard deviation. Okay, calculate the portfolio variance. And you got the square root of the portfolio variance. You have the portfolio standard deviation. Okay, now you calculate the 1-day VaR. Okay, 99% 1-day VaR. So the VaR is going to be, okay, 99%, that's the AE20. So that's the one, 22, that's the Z-score. Okay, or this number is Y right here. So it's 22, you can see this number times 20. So the portfolio standard deviation, that's your VaR. And what is the 1-day expected shortfall? We're using the same formula, it's 12.2. So you get the 1-day 99% expected shortfall. Okay, so I will upload this to an Blackboard so you can see. Also, we'll record the lecture and post on YouTube. Okay, I think that's all for today. Do you have any questions? Okay, now I'm going to stop sharing my screen. And so, okay, keep in mind, next week we do not have any lectures, and today is the last lecture for this semester. If you have any questions, feel free to send your question to my email. And the final exam, the due date is May 8th. Okay, May 8th. And it doesn't matter you are graduating senior or just regular students. So all the students, they took final exam by May 8th. Okay, don't forget to type your name in the chat box